Welcome back again. Now let's continue. Alright, now I'm going to show you how printf provides type safety using verbs. Now I'm going to change the v verbs here. Let's change %v here to s, for example. As you know, planet variable is a string, so I've used %s here. %s means string. It should only be used with string values, okay? Now let's also change %v here to %d because distance is an integer. %d means decimal, by the way. Okay, now let's change %v here to %f. It's because orbital variable is a float. So %f means float. Okay, the last two. Let's change %v here to %s. And lastly, let's change %v here to %t. This is because hasLife variable is a bool. T verb prints true or false depending on the value of the variable. Okay, now all the printfs here are type safe. I'll show you what I mean in a minute. Actually, when you use the %v verb, printf replaces %v verb with a typed verb under the hood. So printf is doing what I've done here behind the scenes. You might ask, why should I use these new verbs rather than just using Swiss knife %v verb, right? It's a good question. However, you need to wait a little bit to get an answer for this. After this example, I'll explain it. No worries. Okay, let's first run this one. As you can see, the result is almost the same as before. Only the orbital here has more precision than the previous one. Precision means how many decimals there are, by the way. Now let me show you what I mean by the type safety. I'm going to change this %s here to %d. As you know, %d should only be used with an integer value, right? However, here planet is a string. Let's see what happens. As you can see, Go warns me with a yellow underline. Go says that planet is a string, but used it a d verb. D verb is only for integers, you smart one. Okay, let's change the others. Now it says that distance is an int, but used a verb for float values. And here it says that orbital is a float, but used a verb for string values. And here, again, it says that the planet is a string, but used a verb for integer values. And lastly, here it says that hasLife is a boolean, but used a verb for integer values. Okay, let's quickly fix those now. So this is what I mean by the type safety. Go compares the type of a value and its corresponding verb. If their type don't match, then it warns you. Sometimes this type checking prevents unintentional errors. So always try to use the type safe verbs instead of Swiss knife %v verb. Alright, this is my recommendation. Alright, now let's take a look at the last example. Here I'm going to show you how to change the printed precision of a float number. You'll see what I mean in a second. Okay, let's first print the orbital, as usual, using the f verb. Now it prints as the previous one, right? Okay, let's get back. Let's add a new line here to make it more readable in the console. Okay, let me copy this one here. Now I'm going to change the precision of this verb to 0. Let's try. It prints 225 days. Much more readable, right? But it has lost its precision. This is what precision means. Instead of printing 224.701 days like here, it prints 225 days as in here. Okay, let's get back. Let's print it with one precision this time. Let's try. The difference is clear. Whenever you increase the precision, it becomes much more precise and at the same time it becomes much more unreadable. Let me add a bunch of these with increasing precisions. Alright, let's try it. As you can see, the precision increases on each line. This means that some verbs have special properties like the F verb. In this course, you're gonna learn about them as you progress, no worries. Alright then, good job. Please work on the exercises if you want to really learn about printf. Thank you for watching so far. See you in the next lecture. Bye. Welcome to the second step. In this step, you're going to learn about the if statement and the condition expressions. And in the end, I'll show you a few example projects using the if statement. Let's get started. Let's take a look at an example if statement. Let's say that you have a program that prints messages depending on a basketball game player's score, okay? For example, if the score is higher than 3, then it will say good. Let's create the if portion of that program now. I'm gonna show you the whole program afterwards, but for now, let's focus on the if statement, okay? Now I'm gonna type if. Then I'm gonna wrap the condition part in the parentheses like this. Then I'm gonna type score greater than 3 using a comparison operator. If statement has its own block with its own scope, by the way. So I'm gonna create a new block now. Then inside the block, I'm gonna type the good message. If the score is higher than 3, then it will print good to the console. So far so good. However, something is missing, isn't it? Yes, in Go, you can type an if statement like this, but you don't have to. Let me show you what I mean. Better, right? I removed the parentheses. Unlike C-based languages, in Go, you don't have to type the parentheses unless you really need to. This version is more concise, isn't it? This statement is exactly the same as the previous one. Now let's take a look at the parts of this statement. This part is the if statements block. You know what's a block, so I won't explain it here again. Just remember that a block creates its own scope, so any declared names inside this if block won't be accessible by the outer blocks, but the if block itself and the following branches. You'll learn what I mean by the branches soon, no worries. Alright, let's continue. This is the condition expression of the if statement. This expression should always yield a bool value. You already know what a bool expression is, right? So you can use any bool expression or a bool value here. As you know, Go type system is unlike other C-based languages. So you can't use any other value than a bool. In JavaScript, for example, you can put any value in a condition expression and it will work, but not in Go. Check out the example that I've created for you to show you this. It's in the resources. Okay, these were the parts of the if statement. They are simple, right? Now let's talk a little bit more about this condition expression. Let's say that your program also evaluates whether a score is a valid one or not. To do that, here, I'm going to use another expression with a logical AND operator like this. As you can see, the condition expression still yields a bool value, right? To combine these two expressions together, I've used a logical AND operator that you've seen before. Now it only executes the if statements block if the score is higher than 3 and only if it's also a valid score. Okay? By the way, sometimes I see code like this which is written by beginners. Here it's clear that valid variable's type is a bool, right? Or I couldn't have compared it with a true value here. If so, then you don't need to type it like this. Let's check it out. This is better, isn't it? As you can see, now I'm directly using the valid variable here. So you can use bool values directly. You don't have to compare them. By the way, let's say that you want to print the message only for the invalid scores. How can you do that? Let's check it out. Here I've used the not operator. So now if statements block will only run when the score is higher than 3 and only when if it's not a valid score. Okay, now let's put this in a program context to understand it better. Okay, good. Now let's short declare score and valid variables like this. Let's say that the player's score is 5 and it's a valid score. So let's initialize the variables with those values now. Okay, let's run it. It prints good message into the console. It's because, as I said, the score is higher than 3 and it's valid. Now let's change those variables. Let's say that the player's score is 3 this time. Okay, now let's run it again. As you can see, this time it doesn't print anything. Since the score was less than 3, so the if statement's condition hasn't been executed. Okay, now let's say that you want to print another message when the score is equal and less than 3. To do that, you need to use an else clause. In the next lecture, I'm going to show you how to do that. So see you there. Bye-bye. Welcome. In this lecture, I'm going to show you else and else if branches, as I promised. And I'll talk about a few rules when using the if statement. Okay, let's check it out. Let's use the else statement with this code. Okay, now I'm going to type else with its own block like this. Else branch can only be used when there is an if statement, so you cannot use it without an if statement, alright? So anything declared in the if statements block will be available in the else block, by the way, but not vice versa. Inside the else block, I'm going to print low like this. Okay, let's run it. It prints low. Let me tell you why. It's because this condition expression of the if statement was false. It's simple as that. So else branches block is executed instead and it has printed low as a message. By the way, else branch is only executed when the if statements all the other branches were false. Let me show you what I mean by the other branches. I've simplified the program a little bit to keep things easier to understand, okay? I removed the valid variable from the if statement's condition. Sorry, but else branch looks a little bit ugly now, but I'm gonna fix it in a minute, no worries. Okay, let's say that you wanna display a special message when the score is equal to 3 as in here. To do that, you need an else if statement like this one. As you can see here, else if branch looks like an if branch because it really is. Like the if statement, it has its own condition expression. Only difference is that it starts with an else keyword and it should belong to an if statement right after the if branch. That's why it's called an else if branch, not an else if statement. Anyways, okay, let me run it. It prints on the edge. Cool. Now let me explain what's going on here. The score is not greater than 3, right? So the first if statement is skipped. And then else if branch's condition is checked. The score equals to 3, so the else if branch is executed. And the else branch down below is skipped as well. That's because else if's condition was true. As I said, else branch only executed when all the branches are false. Now here, I initialize the score variable with a value of 2, okay? Let's add one more else if branch here. It'll execute when the score is 2, right? Okay, let me run it. It prints meh. It's because the score is 2. That's not a good score then. Anyways, now let's check out the rules of the if statement. First rule is that you can use the if branch in an if statement only once. The second rule is that you can use as many else if branches as you want. Sky is the limit. As you've seen, else if branch is completely optional. You don't have to use it at all. And the last rule is that, similar to an if branch, you can use an else branch only once. As you've seen, like else if branch is also an optional branch. It runs only when all the previous branches were false. So in summary, there can be only one if and one else branch, but there can be multiple else if branches. It's that simple. Alright, that was all for now. See you in the next lecture then. Bye bye.